everyone, this is Alicia Mars. I'm a Regional Drought and Information Coordinator with NIDIS, the National Integrated Drought Information System. Welcome to the second Pacific Northwest Drought Early Warning System Drought and Climate Outlook. We do these periodically throughout the year. This one is for October. This is an activity of the Pacific Northwest DEWS and will be ongoing throughout the year. I want to just get started and let everyone know that we are recording this webinar, which will be posted on drought.gov in the coming days. So if you have colleagues or other folks that you work with that you'd like to share it with, you will be able to pass along the link to them for future reference. So to get things moving, because we have a really great jam-packed agenda, I just wanted to give a quick overview of where we're going and what we're going to talk about today. So I'm going to give you a very, very brief snapshot as to what NIDIS is and an intro to the Pacific Northwest DEWS in case you are not yet familiar. And then I'm going to pass it on to John Abatzoglu from the University of Idaho and CERC to go over the current conditions, so a drought update and current conditions throughout the region. Andrea Baer with the National Weather Service Western Region will then give us a brief presentation on the climate outlook, and then we'll dive a little bit deeper into observed impacts and associated mitigation actions for Idaho and Washington from David Hokema from the Idaho Department of Water Resources and Jeff Marty with the Department of Ecology from Washington. And then we are really happy to have the Northwest Regional Climate Hub, so the USDA Climate Hub. So Gabrielle Roche McNally, who's also with the Forest Service, will give us their perspective as well. So in true NIDIS fashion, and especially with the DEWS, we're really happy to have so many different partners from so many different agencies participating. I will note that all the participants are on mute and will remain so throughout the webinar. We have a really great attendance for this webinar, so if you do have questions throughout the presentations, please pop them into the chat box on your screen, and we are monitoring them. If we're able to answer them quickly, we will throughout the webinar, but we've set aside a little bit of time at the end to address hopefully any questions as needed. So what is NIDIS? If you are not yet familiar with NIDIS, we are the National Integrated Drought Information System. We are a NOAA program, but we have an interagency mandate from Congress to help coordinate drought and climate information to better, to enhance drought early warning and help communities prepare for drought and mitigate it better from an interagency perspective. So we really, as I referenced before, rely heavily on our partners at every level of government and sector to create a robust drought early warning system. One of the tasks of NIDIS is to create a national drought early warning system, and in order to do that, we're taking a piecemeal approach. And as you can see on the screen, there's a map of the regional drought early warning systems that have been created so far. So the Pacific Northwest DEWS is the region we're focusing on today, and you can see the slide on the slide there, the states and regions that it encompasses. So many people often ask what a drought early warning system is. They really come in many shapes and sizes, but they reflect the special attributes of each region. And essentially what we're trying to do with a drought early warning system is not replace the existing partner networks and information portals that exist within a region, but hopefully enhance them and help spread the word to better enhance this concept of drought early warning. Drought early warning is essentially hoping to make climate and drought science more readily available and easily understandable for decision makers in the region at every level of government. And we also want to help stakeholders better understand and use and monitor this information so that they can better plan for and cope with the impacts of drought. So the Pacific Northwest DEWS is one of our younger DEWS. We officially launched this DEWS in February of 2016 at a great meeting in Portland. We, as with all the other drought early warning systems, are developing strategic plans for each of the DEWS. These are 2-year living documents that will help provide a roadmap for the activities that we plan to undertake over the next 2 years. And then also they provide an opportunity for us to show what the needs are of the stakeholders in the region so that they can leverage that information as well within their organizations. So some of the takeaways, and I'm not going to get very deep into this at all, that we've outlined based on our conversations throughout the last year or so in the Pacific Northwest is that the drought of 2015 is definitely the new drought of record, and we're utilizing that as an opportunity to reflect on recent activities and experiences and then better prepare for drought. We definitely see there's opportunities for additional research and monitoring in many different sectors. Some of them are listed here on the screen. We want to identify specific triggers to help inform operational decisions. There's a great opportunity for improved communication and outreach, and it's a very receptive region. And we also want to better leverage existing information and collaborative networks, of which there are many, many great examples of that already in the Pacific Northwest. So one thing that I should say too is that the Pacific Northwest DEWS, or one of the primary activities of a DEWS, is to better are these climate and drought outlooks. And so we have a great lineup of folks today that are going to provide drought and climate outlooks. And I want to pass it over to John Abatsoglu here. And so John, I'm going to advance your slides. So you should see that now, hopefully. Are they popping up yet?
I don't see anything yet.
I'm just getting, what is wrong with GoTo? All right. Let's try this again.
There we go.
I think we actually overloaded our attendance, and so it froze my screen.
Oh, that's great.
So.
Okay. Well, thanks, Alicia, and a happy belated water year to everybody. What I wanted to do, and we can advance to the next slide here, is let's start off by reviewing the drought monitor maps that were released this morning. And those are shown on the right here. And we're comparing those to where we were basically this time last year. After the 2015 drought of record, we clearly can see that overall the region has recovered from drought to some degree. We do see across the Northwest sort of generalized drier than normal conditions. There are a few areas of drought, namely areas in northeastern Oregon. We can see some also in western Montana and also sort of near Yellowstone National Park. But the overall message is that we have seen some drought abatement across the greater area. And we can head to the next slide. And I actually gave a water year outlook in Boise about a year ago, and things didn't look all that great for the Northwest, given that we had a pretty good ongoing drought, and we were facing the prospects of a strong El Nino year. And lo and behold, the El Nino of 2016 brought the Northwest above average precipitation for the most part. And this is showing us the water year precipitation percentiles. And this is from the Westwide Drought Tracker, product that I sort of still run. It's at the Western Regional Climate Center. And so we can see a lot of areas here of above average precipitation, and also there are several areas, if you sort of look at the sort of the Puget Sound, a little bit of the northern Willamette, and also the eastern slopes of the North Cascades, of precipitation in the sort of the top 10 percentile of the 120-year record. So that was a pretty good outcome given the prospects of an El Nino and where we sort of started out last water year. You can see also here there are a few areas as we move over into the eastern portions of the Northwest, sort of the eastern mountains of Idaho and western Montana, that actually had a little bit below normal precipitation, and that's primarily a product of the climatology of those areas the precipitation tends to occur more towards spring and early summer rather than sort of midwinter like we see across much of Oregon and Washington. So we'll head on to the next slide here. And I thought I'd put this in a little bit of context. We usually think about sort of El Niño and La Niña as being sort of two sides of the coin. Generally we think about La Niña years as being wet and cool, and vice versa with El Niño years. And in this plot here, what I'm showing is a scatter plot of the multivariate El Niño index for basically for winter on the x-axis. And then the y-axis is the water year precipitation for the Northwest. And this is just Oregon, Idaho, and Washington area weighted. And what's interesting is if you look at the top 3 El Nino years, indicated by the dots furthest to the right on your screen, so those are the 3 strongest El Nino years, and they actually have all resulted in slightly above to significantly above normal precipitation for the Northwest. So there's something sort of interesting with these strong El Ninos, and it just so turned out that we didn't dig ourselves into a sort of a deeper deficit this past water year, which is great for sort of drought recovery. Next slide. So I wanted to quickly sort of provide an overview of how drought conditions have evolved this summer and then focus in on September. This summer we saw a little bit of a mixed bag in terms of temperature. Overall, it was actually the coolest summer for the Northwest in 5 years since 2011. But interestingly enough, we also saw a relatively dry summer. Not that we received a lot of precipitation in the summer, but especially across much of the interior portion of the Northwest, precipitation was below average. And that allowed for a little bit of drought development, particularly in sort of the eastern portion of the Northwest. If we move on to the next slide. This is September, and September was generally cool across the area, and that was a response to basically a sort of generalized troughiness across the Northwest. Much of the rest of the country was well above normal, so we were a bit of the exception. The precipitation signal, again, September is a pretty dry month typically across the region, but there were a few bouts of precipitation that impacted the area. There were a couple systems that came through basically along a west to southwesterly trajectory. These are sort of marginal atmospheric river type events. And in particular, if you focus in on sort of the precipitation in Washington, you see these, stark contrasts in the precipitation anomaly between the west and east slopes of the Cascades. And there was an event that brought upwards of 3 to 4 inches of precipitation somewhere around the 3rd week of September along the westward slopes of the Cascades, and pretty much nothing in the lee of the mountains there. So that was a really nice sort of orographic event. Due to the strong lower level flow and high moisture values typical of atmospheric rivers. And then if we focus in on sort of the southeastern portion of the domain, we see well above normal precipitation. And in fact, I drilled down to a couple locations there, and I think there were a couple areas of 600% above normal. And again, we're starting from low baselines. But that was primarily a consequence of sort of an upper level low or a cutoff low across the Great Basin, advecting the remnants of former hurricane tropical storm Payne across to Nevada, Utah, and into southern Idaho. So it turned out that a couple locations in southern Idaho, actually in Snake River Plain there, saw their wettest September on record, primarily coming in a few-day period with some heavy rain. Move on to the next slide here, and I'll go through a few summary slides of drought metrics. And I'm highlighting here a product that CIRC, the Climate Impacts Research Consortium, is working on, and myself and Bart Nietzen from the University of Washington are working on. It's called the Northwest Climate Toolbox. And we're basically updating a number of products on a daily basis, and we're also open to listen to what the community is interested in terms of sort of spatially explicit climate and drought products. So this is one product actually that we developed over the summer in response to a conversation we had with a stakeholder. And this is showing us, at least for the last 90 days, a measure of the atmospheric demand. So this is potential or reference evapotranspiration expressed as a percent of normal. And you can see basically above normal and below normal conditions. The below normal conditions across much of the northern portion of the Northwest, and that's a response of basically cooler than normal temperatures, and also a little bit higher relative humidity values. Across sort of the southern and sort of southeastern portion of the Northwest, we do see some above normal potential evapotranspiration or demand values that are coming in there, and that's a response to warmer and drier than normal conditions. Move on to the next slide. And we did see some fire in the Northwest this summer, nowhere near 2015 or even 2012, 2013, or 14. We did have a few large fires that burned. Primarily, we had some active fires in Yellowstone, and then we had the Pioneer Fire that burned in the Boise National Forest. And this is showing us one measure of basically fuel aridity for this past summer. So this is June 1st to the end of September, and this is some data that's coming out of Climate Engine. It's a product that myself and collaborators at the Desert Research Institute have developed, and it's also being supported in a cross-DEWS effort with the Northwest and California, Nevada. So we have a lot of products that are on there. This is showing us the energy release component departure from normal, and we can see basically the areas that did see a lot of fire this summer. The sort of the central mountains of Idaho, mainly in the Boise National Forest, and then in Yellowstone being above normal. The rest of the area is sort of pretty close to normal, well below actually the last 15 years or so. Next slide. And then one more sort of integrated measure of drought. This one is through the lens of remote sensing. This is showing us basically a measure of departure from normal in terms of vegetation greenness for this past summer. So the sort of the warmer colors are showing you basically below normal levels of greenness, indicative of more aridity. And the green is showing you the opposite. And basically here I'm highlighting much of sort of central Idaho, western Montana as seeing somewhat below normal vegetation greenness, suggesting some drought stress. There are some blobs that you see in red, and those are actually fires that have occurred in the last few years, and the greenness obviously is not so bright there, given those landscapes are quite changed. Next slide. And then a sort of a nice way to summarize this is by using the integrated measure of drought. And so this is a product that is being sort of run by Bart Neeson with the Computational Hydrology Group at the University of Washington. And this is showing us basically that the total soil moisture and any sort of snow water equivalent across the area expressed as a percentile relative to the historic record. And this is a really recent plot. So we can see, across the Northwest, there are some areas where we are sort of below normal in terms of total soil moisture. And that sort of generally jives with the drought monitor maps that I showed you at the very beginning. You can see also some of the areas in sort of the southeastern portion of Idaho being above normal, and that's a consequence of the wet conditions that we saw later in the half of September. Next slide. And it is snowing, so we have seen some snow here in the last few days. This is a shot from Silver Mountain Resort in Kellogg, Idaho, and that's a good sign. And we can go to the last slide here, which summarizes things. So basically, we have seen some drought recovery in the Northwest after last year. We actually saw one of the coolest summers in 5 years, and that was responsible for a little bit of a subpar fire season. Things were cooler and somewhat drier than normal in September, and consequently we're commencing this water year with a smaller deficit than we were last year. And that's what I have.
Okay, great. Thank you so much, John. I think we're gonna try to slip over here real quick to Andrea's presentation. Kathy, are there any questions while I'm loading Andrea's?
I don't see any.
Okay. All right. So next up is Andrea Bear.
Thanks, Alicia. Appreciate it. I'm Andrea Bear. I'm from the National Weather Service in Western Region Headquarters, which is in actually Salt Lake City. And most of my slides come from our Climate Prediction Center. And I just wanted to start off with two little graphic cartoons there because it really does say where we're at right now. With ENSO, we're really on the borderline between ENSO neutral and weak La Niña conditions. So those are just two cartoons that depict the typical conditions. And next slide. I am going to start with the summary and end with the summary. In early September, the Climate Prediction Center dropped the La Niña watch that they had issued back in, I think it was April, because really the conditions and the models for the last few months have been trending more towards ENSO neutral. So they decided to cancel that La Niña watch in early September, but they did say, and wrote and everything, all of their little descriptions and everything, that it is possible that we could, go into a La Niña event. So they do still say that, but currently right now we're in ENSO neutral conditions. The sea surface temperatures along the equator are near or below average. That's in the East Central and the Eastern Pacific. ENSO neutral conditions are slightly favored in our outlooks, between about 55 and 60% probability that ENSO neutral will remain through the fall and winter. But as you can tell from those probabilities, La Niña still is in play and could still be a possibility. So my last bullet on this page is definitely stay tuned. We are in a borderline between a cool neutral and a weak La Niña situation. We will have the latest discussion that will be updated next Thursday, and that link is down there in that little box. That will be out next Thursday morning about 9 a.m. Eastern time, and they'll go through the latest conditions and where we're at. It would have been ideal to give you this briefing next Thursday with that latest information, but I just want to advertise to stay tuned and look at that next week to see where we're at status-wise. So next slide. So a real quick recap of the last year. You can definitely easily see that big red area, which was our strong El Nino, and then cooling off in the spring, March, April, and into May, and then moving into cooler or below average sea surface temperatures. And since late August, we've seen a little bit more average to slightly above average creeping up in the very far eastern Pacific. But for the most part, the central and the central eastern Pacific are still below average. Next slide. So during the past month, the equatorial SSTs, they were near or below average across, like I said in the last slide, the central and east central Pacific. This just gives you another viewpoint of that point, but you can see that nice cool area right there along the equator and just east of the date line there. Next slide. And then during September, the weekly departures from normal really decreased across the central and the western Pacific. But you can kind of see along the equator there where some areas did warm a little bit from that cooling that had been taking place late summer and as we transitioned into fall. So next slide. This shows you the weekly sea surface temperature departures. We look at that Niño 3.4 region, that region in between Niño 4 and Niño 3. And what we're looking for there for a La Niña is about, starting a weak La Niña about negative 0.5. And again, this is weekly. We really do look more and take more into account the monthly averages, but this is weekly. So you can see things are on a weekly time scale cooling off a bit in that region. So we are definitely, our forecasters are paying attention to that and looking at what that means for the outlook as we move through the fall. And next slide. This just gives you a nice view of the upper ocean in the central and the eastern Pacific, and it kind of shows you back in March and into April where we transitioned from the El Nino, things cooled off and we moved more into the cooler territory in that upper part of the ocean. It tapered off a little bit as we got into the summer. And again, on a slight downtrend towards cooler as we're moving into fall. Next slide. So this slide really shows you where we're at with trying to come up with a decent idea of the forecast or the outlook. So on the top, you'll see the early September ENSO forecast, and you can see there the green bars indicate neutral territory, and things really did look like we were moving into remaining neutral and not necessarily transitioning into La Niña. So they, again, the CPC did favor slightly the chance of staying in ENSO neutral conditions. But when the mid-month models came out, things are looking a bit cooler. And again, La Niña is a little bit favored there, but again, we're on that borderline, so you know, they've got about a week to look at all the models and get all the model information in to really figure out what they feel like the future is going to hold for the outlook. But you know, this just really indicates the tricky part of that job that they have, because there are these subtle differences. But again, my big message is borderline here, borderline cool neutral to weak La Niña. So moving on to the next slide. This also shows you a different view of the model output, both our dynamical tools and our statistic tools. Again, just showing you really how borderline this the situation is, both current conditions and the models. It's kind of hard to see, but there's a thicker yellow line in there, and that gives you your average. And again, just as we move through the fall and into the winter, really borderline there. So that's my screaming message. Next slide. So this is a history of, I went back to, or CPC went back to 2004, just looking at warm episodes or El Nino episodes and La Niña episodes, and kind of showing you where things are. So you can see from April, May, June season there in 2016, we started to cool off. And then as we moved into the summer, we really started cooling off. The numbers just came in earlier this week, and it's not on this slide, but the July, August, September seasonal average is negative 0.5. So just right on that borderline, right on that threshold between neutral and weak La Niña. So that, again, makes the case for what I'm telling you about the borderline issue. So moving on to the current outlooks. These will be updated with our winter outlook. That will be released on October 20th. It's a Thursday. So I would expect them not to look terribly different. Basically what they've done here is they have a bit of a La Niña feel to, or yes, La Niña feel to them. They just backed off a bit because of what I was talking about earlier. So they decreased their size of those areas that are favored to be wetter than average or drier than average. So I would suspect that when the outlooks come out, now I'm obviously not doing the forecast, so I don't know, but I would not expect wild swings or deviations in this. But as you can see, as we move out of fall and into winter, a little bit slightly favoring wetter conditions, especially on the eastern side of the Pacific Northwest. And then looking at temperatures on the next slide, really slight favoring of warmer than average through November, December, January. And then after that, our tools really don't indicate one way or the other. Really there are equal chances for temperatures to fall in normal or above normal or below normal. So really not a lot of information forecast-wise. as we move into winter for temperatures. And with that, I'm going to come back to the summary slide. Again, a little bit of a tricky time to do the forecast since we're right on that borderline. But please stay tuned. That link below there will give you the latest update to the ENSO situation on next Thursday on the 13th, and then the week following that will be our winter outlook. So thank you.
All right, thank you, Andrea. I think the uncertainty is clear, but important to recognize. So I'm going to now pass it over to David Hokema with the Idaho Department of Water Resources. All right, and David, we can't hear you, so I'm not sure. Are you muted? There. Try that. Are you there, David? I think we're having a few issues hearing David, so I think I'm gonna, Jeff, Marty, are you available? We'll go with you, and then we'll try to bring David back on.
Sure, I'm ready to go.
All right, let's swing over to Washington. So let me grab your slides here. All right.
Okay.
So, Jeff?
Thanks. All right. So I will give an overview of, I guess, Washington's water year and our drought conditions and how we actually analyzed this year, whether in fact we needed to have a formal drought declaration of any kind, and whether we forecasted there would be problems or not, and then whether or not that actually transpired. So Washington, we had what I call a pretty normal, mediocre water year that relative to last year actually felt pretty glorious. And the National Climate Data Center statistics on our water year as a whole just became available, I think, today. And so we had the 12th wettest year, water year, going back to 1895, and the 4th warmest. And it was mostly wet the first half of the year. It did dry out a bit the last second half of the year, I think, as John indicated. So if you can move to my next slide, and I wanted to just give an intro to, because Washington has statutory criteria for drought conditions are that are defined by the legislature. It's very hydrologic, water supply oriented definition. And essentially, we have two major criteria that have to be met for drought conditions to be considered to exist, in the state's view. And these are different than the criteria used by the drought monitor at the federal level. And the first criteria is whether or not a part of the state, a watershed, would have less than 75% of normal water supply. So think of normal as average or median, 75% of that. And then secondly, the second criteria is a hardship. It's a social criteria. And that is whether, because of that or related to that water shortage, do we expect to see severe impacts economically, environmentally, or with respect to drinking water, public health. And if we make a determination that those two criteria are met, then the state can go forward with a formal drought declaration process. And so some of the next slides I'm going to show you kind of show the conditions we looked at this past year and made that decision, yay or nay. Next, please. So this is just a slide real quickly. it shows we have a water supply availability committee that looks at water supply and river forecast information throughout the year, and especially in the winter months when the snowpack is developing and the river forecasts are coming into kind of greater certainty and clarification. And so last spring, when we reviewed the river forecast information for our watersheds throughout the state, we identified that 25 out of 62 watersheds actually were forecasted to meet the hydrologic portion of our state drought criteria. And you'll notice that by and large, most of those are on the west side, and then a few over in southeast Washington. And last year, by contrast, we had, I believe, 48 out of 62 watersheds that were forecasted to meet that criteria. Next, please. So we had, a number of watersheds that were forecasted to meet the hydrologic criteria, and then we looked at, okay, well, in those areas, what's the likelihood that we're going to have, hardship in those watersheds? And one of the things, not the only thing we looked at, is, well, what's happened in past drought years? Where do we see lots of activity in terms of requests for emergency water right permits? And that's an authority that becomes activated in a formal drought situation, help people get emergency water sources or emergency water right transfers, that sort of thing. And you'll see these are 3 maps and these are all years in which the state declared statewide drought. And you'll see that by and large, most of the activity tends to be clustered on the eastern slope of the Cascades on the east part of the state. And that's an area of the state, it's the dry side, heavily agriculturally dependent, nearly exclusively dependent on surface water for irrigation in a number of these watersheds, and especially in the Yakima Basin, which is that real intense cluster in the south central part of the state. And in drought years, we will see a number of farmers in some of the junior water districts want to resort to emergency wells to compensate for the lack of surface water supply. But we didn't see, when you remember those areas on that previous map where the water supply is going to be below 75%, not a big overlap with a high density or high probability of emergency permit activity. So we did not actually declare drought this year, even though we had a number of watersheds that met the hydrologic criteria, because there was not sufficient information that sort of imminent hardship was going to occur. Next, please. And so this is a water watch graph from USGS using data that kind of shows how this year's water year proceeded and compared to last year's water year. And you'll see on the left vertical axis, it's the percentage of stream gauges in Washington that fall within a kind of a percentile category, record low, much below, below, and so forth. Record low means, the gauge on that day was the lowest observed value for that day a year for that gauging station, much below, less than 10%. Last year, we had sustained periods where 80% of our rivers were below normal, and we had also sustained periods where 30 to 40% of our rivers were establishing record low flows for that day of year. And those days kind of clustered in what would normally be what is our snowmelt season, late May through early July. This year, you'll see, the picture was not quite so bleak, and we did have, 20 to 30% of our rivers in May and June that were, much below normal, but we didn't have kind of sustained periods like last year, and it wasn't as severe, in terms of having lots of record lows being established. And so we worked through the summer, and to the point where essentially, things were like 30 to 40% of our rivers were below normal. So things tilting slightly below normal, but actually pretty close to average as well. Next. And so this is just another view of our flow data for the April through September season, and this is a volumetric ranking. And so you see all these little flags, and these represent gauging stations, and the value is the rank that the volume of runoff April through September compares for the past 68 years. And so, and it's a descending order, so a 1 means that that was the lowest volume, the driest year in the past 68 years, a 2 second driest, and so forth. And what's really interesting is that this year we had a number of gauges, particularly clustered on in the southwest part of the state, where we had volume of runoff April through September that was lower than last year, which was our drought of record. And I think that's probably might be explained by perhaps some hangover effect from last year, but also this year, April and May were quite dry in southwestern Washington, and I believe that that probably detracted from the overall volume of April through September. Next, please. So water supply impacts for Washington, and a lot of this information it becomes available over time, but thus far, looking at the NAS crop progress reports, good year for agriculture in Washington. Obviously some coping here and there with dry and warm conditions. Things progressed very early. Things were ripening quicker. We had raspberries a month early north of Seattle. The cranberry bloom in Pacific County on the coast was the earliest in recent history. The Yakima Basin, which is our key watershed for agriculture in the state, had a 100% supply for senior water right holders, ended the year at 94% for proratable irrigation districts, compared to last year, which was 44 to 47%, so much better. We did have low flows, low enough flows that we needed to curtail junior water rights in some watersheds, so we curtailed about 600 water right holders across the state this year. Big difference for this year compared to last year was the temperatures. Last year, some really sustained severe heat waves that caused or contributed to catastrophic losses of salmon and sockeye on the Columbia River. This year, much more moderate, so we didn't observe those kinds of impacts. And in terms of impacts to public water systems, it's always difficult to have a good handle on how they're coping. We don't have a process in our state to systematically track that or have them notify us. But there were just a few reports of cities asking their customers to do voluntary water conservation. Next, please. So it's my last slide, I believe. And so looking forward, just so I let people know that in our state we are updating our state drought contingency plan. And right now in our state we have 2 stages essentially: no drought and emergency. So we're considering going to a system where we'd have multiple drought stages, similar to some other states, to kind of give us more a better, I guess, communication arsenal. And a better way to message conditions to the public. And we're looking at pre-staging of response actions so that when drought does occur, we're ready to hit the ground running as that spring water supply situation becomes more obvious. And we're looking at approaches for improved forecasting, and our Office of Washington State Climatologist is leading a subgroup of experts to look at that topic. And we have a final report on the 2015 drought impacts to agriculture that is due in December. They provided an interim report last year, which put the cost at about $335 million. That was only looking at about 5 or 6 crop types. This December, they're going to expand that to some more crop types. I think we might get up to 15 or so. And there's indications that economic value cost is likely to double. So look for that in December. And then just wanted to let people know that if they are interested in following Washington's Water Availability Committee discussions, shoot me an email. My email's on the first slide, and I can add you to the invite list, and then you can listen in on the meetings, and then we also have time for participation as well. So that's the end of my slides. Thanks very much.
Great, thank you so much, Jeff. That was really a great presentation and a great way to drill down into what's happening in Washington. So I think, David, can you, let's see if we can hear you. I think you're muted again. Let's try now.
Okay, can you hear me now?
You are. Okay. I'm going to pass you controls so we can get an update on observed impacts in Idaho.
Okay. You should be able to just see my
Here we go.
PowerPoint slide up.
Yep, looks good.
Okay. So I'm just going to go quickly through some slides to indicate kind of where we were at and how things are looking. When we started at the end of the last year in August, John showed October, which was a little more severe than August, but basically we had extreme drought in northern Idaho and out in the Hawaiis, and then more moderate as you went to the eastern part of Idaho. And then on the left of the screen we have a snowpack accumulation map that shows the peak that we reached compared to the median peak. And then you'll notice in there's the 2016 peak date and then the beginning of the melt-off, or the median peak. And so if you look at the Hawaii, you'll see that the Hawaii peaked about 18 days early and then melted off somewhat early, and that pattern follows for the southern region. But notice how the snowpack was best along the southern Idaho border with a little above normal in Weiser, and then the Birch Medicine Lodge camas, that doesn't have a lot of snowtail sites, so you can take that with a grain of salt. But in general, our snowpack looked pretty good across the state. And then that's reflected in this 12-month SPEI index, which shows 12 months ending in September of 2016. We have some dryness over in the Yellowstone region, but elsewhere a little below normal through the central mountains, and the SPEI is a little on the wet side, and that's probably mainly because of September being so above normal down there in southern Idaho. If you look at just the 6-month SPEI, which would be the irrigation season from April through September, you see more of a severe level of drought over Yellowstone and what would appear to be a severe level of drought in the mountains of central Idaho. However, when we go back and we look at the 12-month indicator, which is more of an indicator of where we were at for snowpack for the water year, we don't see that, and that had a big impact overall on our water supply this year. So we never labeled this as drought in our recommendations to the USDA, but we did indicate drought over in eastern Idaho. When we look at the way the summer played out, on the left we have the April through June mean temperature departures, and overall the Pacific Northwest was much warmer than normal, especially in the mountains of central Idaho and over in the Yellowstone region and up in northern Idaho. But then in July, the July through September period, it kind of switched over, and we still remained a little bit above normal around the Yellowstone region, but really cool through the Snake River Plain, which is interesting when you consider John's graph that indicated evapotranspiration was slightly above normal in the Snake River Plain, and we saw that reflected in our priority dates and water usage. And so when you look at precipitation from April through September, we see it was pretty much dry except kind of in that southern Idaho region. And so in our recommendations to the USDM drought monitor, we showed some drought up here, and that corresponds to our 3 state drought declarations, one which was in Jefferson County. There was one in Limhi County and Custer County, but we didn't reflect those in the USDM. And so when we consider where we were at last year, we had seen a severe drought over in the Hawaii region, even an extreme level of drought in the Hawaii region for a couple of years. But this year it recovered because of the high snowpack, and the early runoff was captured in the reservoir. You can kind of see that runoff peak. When you look at the reservoir, you can see the reservoir fill pretty quickly in February, and so that took us out of the water supply shortages for the Hawaii Basin, and then it tapered off at a pretty normal rate. And now we're starting the year out over here with significant carryover. So it's looking a lot better on the Hawaii going into this season, and last season this 2016 year was a good season. But on the Upper Snake, we saw reservoir declines, which were the 3rd highest water usage in the state since 2000. And you can see we came into the year looking fairly in a reasonable position. And then the runoff started early, and the reservoir started draining early and continued to decline fairly rapidly until the September rains came in, which kind of tapered off the tail end of the season there. But the water use in this period was quite high, and because of the dryness over the winter, a lot of the headwater streams, the inflow into the Upper Snake was pretty low, and so we hit really low priorities, which caused the storage to decline pretty rapidly. And if we look at the priority dates on the Upper Snake River, this comes from the state's water right accounting model. I've got all the years shown here, but if you look at 2016, we came off pretty rapidly, and then we went into very low territory, which if you go over to the right side of the graph, we have our 2 most severe drought years recently, 2001 and 2007, where the priorities were down in the upper 1880s. And then this year we came right along there, and I think in part because the good snowpack made it appear like we'd have a better water supply, but then that early melt-off resulted in the natural flow in the system declining rapidly, and a heavy reliance on storage use throughout the year. And if you were to take the priority dates in August, you'd see that they were hovering right along these more droughty years. And so that was the main impact we saw on drought in Idaho, was in the eastern Snake Plain, where irrigators were taking voluntary measures to rotate usage by canal to extend to keep the water right priority lower, and to try to extend their natural flows use. But it still brought the reservoirs down low, and this is the one area of the state we're really looking at in the coming season to see if we get the adequate snowpack to refill the reservoir system. And with that, I'll leave it for questions.
Okay, great. Thanks, David. I'm going to pass control again here over to Gabrielle, who's with the Northwest Climate Hub. And we're really happy that she was able to join us. And Gabrielle, let's test your audio too here.
Can you see my screen?
Can.
Okay. I should probably. Oops. Sorry. All right. things look different to me than they do for you. I'm assuming things look normal on your end?
We see the presenter view.
Oh. Oh, geez. All right, does that work?
That looks great.
Okay. All right. Well, I know we're running short on time, so I'll try to make this fairly quick. So, yep, I work with a Climate Hub. I'm the fellow there, and you can see my colleagues down at the bottom of the screen. So the hubs, part of, my presentation is a bit different than what you've seen already this morning, but I'm kind of broadening it out to tell you a little bit about what the hubs are and then also some of the work we're doing in the region. So I hope folks find this relevant. So the hubs are a regional network, and we're really tasked with assisting land managers and those who serve them, so from federal agencies to extension to private advisors, and really helping them to assist and respond to risks due to a changing climate, which include many of the things we're talking about, drought being one of them. So the hubs are focused on managed lands from farms, forests, and rangelands. We provide technical and program support, assessments and forecasts, as well as outreach and education. I'll note that I'm working with the Forest Service, but we actually serve a broader group of stakeholders and land managers. The hubs are funded by a diverse group of USDA agencies. So within the Northwest, we serve Alaska, Oregon, Idaho, and Washington. And this is just a little snapshot of our website. I welcome you to go on there and take a look. We have a lot of educational materials, blogs, etc., regional assessments, as well as building out sort of regional data and research, including data visualization, as well as tools, some tools that have been developed from some colleagues around the call right now, as well as news and events. And we're really trying to sort of increase our engagement with stakeholders and looking for different ways to do that. I didn't mention it before, but the reason why I'm presenting about the hubs is that we're a fairly nascent organization, a new part of the USDA, and we want our colleagues and partners to know about us and what we're providing in the region. So I apologize for the wordiness of this slide, but what I wanted to do is just sort of take a higher level view about some of the things we're thinking about specific to agriculture, about some of the climate change impacts expected for our region. The Northwest is incredibly diverse in terms of agricultural production, so we expect heterogeneous impacts across geographic scales as well as cropping systems. There are a lot of different impacts in terms of things that we're expecting due to climate change, such as increases in maximum dry days, more precipitation falling as rain, lack of snow, something called snow drought we're thinking more about. Again, we talked about this already today, as well as more extremes between droughts and flooding, things like decreased chilling hours, which has a real impact on tree fruit, increased heat stress and temperature with livestock and plant effects. So then we're also looking at secondary impacts. So what are the pest and disease dynamics, as well as my training as a social scientist, and I'm really thinking about what are the adaptive management strategies of land managers. So are they maladapting to potential climate changes? And we could have a long discussion about what that might mean, or are they purposely adapting? So that's a lot of the conversation and the literature right now, excuse me, is sort of engaging on that topic. And then finally, some of the things that folks are already doing in our region is changing their irrigation. There's a lot more dry farming happening in Western Washington, Oregon, shifting cropping systems, new genetics and varietals, as well as climate impacts, both yield productivity. So, can you still hear me over there?
Yes, yeah.
Okay, sorry, I've got someone calling in. I know that I'm sort of running low on time, so I think I'll skip ahead and just highlight one tool that I hope folks can kind of pay attention to. So we're developing and supporting the development of a tool called AgViz Logic, and within that tool there's a specific AgViz climate tool that is going to help farmers make decisions in the context of a changing climate. So it takes climate data and looks at climate indicators and metrics and helps them to assess what potential impacts from a shifting climate might be on their productivity as well as their yields, and how that might influence their bottom line, and then it will help them kind of think about decisions they might make in terms of adaptive management. And I'm currently working with a team who's developing that out of Oregon State, and they're looking at a broad suite of variables that I don't have time to get into right now, but they're incorporating these and working with farmers to try to better understand what some of the key climate variables actually have the largest impact on on their particular cropping system. And then we're doing a whole slew of additional work to try to get a better sense of what the needs are in the region specific to agriculture in the context of this conversation, but we're also looking at needs within forestry and rangelands. So yeah, and then here's our contact information. I apologize, that was a little bit short here, but I just wanted to be cognizant of the time and give you a sense of what the hubs are doing, and I'm happy to follow up with anyone more in the future if you want a little bit more detail about some of these projects. So thank you.
Great, thanks, Gabrielle. And I should note, in addition to have the recording of this webinar on drought.gov, we'll also have access to the presentations that you've seen today. So in addition to the contact information for the folks that have been speaking. So I just wanted to circle back here and finish up real quick with a couple, just a heads up on some upcoming events that are happening throughout the region. So we have currently under development, and when I say under development, we are working on the registration page and have just recently solidified some locations. The Inland Pacific Northwest Water Year Outlook for 2017, and so that is a meeting that's being hosted by NRCS, Idaho Department of Water Resources, Idaho Power, CERC, and NIDIS. Here we're hoping to support that. That'll be on November 10th of this next coming month at IDWR in Boise. And you've probably heard from Kathy Dello and some of the other folks at CERC that the next Northwest Climate Conference is coming up very quickly as well, the following week in Skamania on November 14th and 16th. And so early registration ends next week, so that means that prices are going up, so please do get your registration in soon. AMS is having their annual meeting in Seattle in January, so if you're interested in attending there, the links are on the screen. And then another partner conference that same week also at Skamania is the Climate Impacts to Water Conference, and so they are still accepting abstracts through November 1st, and registration is open as well. So if you want more information, you can get the links to these again and the presentations that'll be uploaded onto drought.gov here in the coming days. So with that, I'm just going to wrap things up. Kathy, were there any pertinent questions that we wanted to address? I know we've gone a little bit over, but we can probably squeak some out if people are still on the phone.
No, I don't see any questions, but the offer is open to email any one of us and we can connect you with the right person.
Okay. Great, and so I think we'll be planning to hold another webinar just like this, probably in January, because we recognize there are so many upcoming meetings and with the holidays and everything else. But please stay tuned. As Andrea mentioned, the CPC Outlook, the updated Outlook, will be coming out next week. And we'll continue to use this format unless we hear otherwise, where we provide an update of the regional drought conditions, a climate outlook, and then reports out from throughout the region, not just from our regional state partners, but from also other federal partners. So we're really excited to have the Hub on board and working with us as we continue to kind of develop this drought early warning system. So with that, I will close things down, and thanks for sticking around, and we'll talk to you all soon.